Hello and welcome to the discussion on utility theory. So what we're going to talk about in this video is expected utility theory, risk profiles, and how to make your own utility function. So subjective expected utility theory is this idea that we rationally can approximate our choices or our outcomes to some kind of number, some kind of value, and that's what the utility function gives us, is the value of a particular outcome. Okay. So where does it all come from? Well, the big players were von Neumann and Morgenstern, whose famous book was The Foundations of Game Theory in 1944, the theory of games and economic behavior. And in that, they came up with some axioms that they said, hey, this function needs to satisfy these certain axioms. And what are these axioms? Well, one of them is going to be complete. So what we really need is that if you're given two alternatives, either A is preferred to B is preferred to A, or there are indifference between the two. It's got to be transitive, which means that if A is preferred to B and B is preferred to C, then A is preferred to C. That's actually a more complicated one for humans. You'd think that we were transitive, but we don't necessarily transitive in our choices. There's also other problems as well with that. There's non-transitive dice, which can cause problems there. That I might prefer one dice to another in a game, but not to the third one may not be preferred by the first one. Okay. So the third option is looking at there being some connection between three preferences. So if A is not as preferred as B and B is not as preferred as C, then you can construct some unique probability such that the probability of times A plus 1 minus the probability times C equals B, effectively the utility of B. And what does that mean? Well, it's the idea here. So imagine I've got three alternatives. Alternatives might be, washing dishes, eating an apple, or eating a chocolate bar. Okay, now if I turn around and say, well, if you go home, there is a big chance that there might be a nice chocolate bar for you there. There might be a 50% chance of a chocolate bar there. Or you might have 50% chance you're going to find out you're going to have to wash the dishes. Whereas if you stay here, you could just hang around and there's will be apples will be delivered and you can have one of those apples. So I'm just like, in that case, I'm indifferent. Go home, maybe end up doing the dishes, but I might get a chocolate bar. Or I could stay here and get the apple. So that's what's the idea behind that third axiom. So the last axiom, independence, is the idea that if A is preferred to B, then if you have some kind of probability distribution involving a new alternative C, it doesn't impact that. It doesn't impact the fact that A is still preferred to B. Okay, so if you look at this equation here on the right-hand side of the independence bulletin, you'll notice that if I, as you expect, if I minus 1 minus P times C from both sides and then divide through by P, assuming that P is greater than 0, then A is greater than B, so A is preferred to B. Okay. So just carrying on with a further more discussion on the history. The only crucial one here that I think you need to know is Kenny, 1974, just suggested saying, hey, you've got utility functions, because it's arbitrary, why don't we just make it like between 0 and 1? There is no infinite utility. So 1 is the absolute maximum someone could ever achieve from anything. Hey, and if you're going to put some weights in there when you're evaluating things, let's make them between 0 and 1 as well. So just the idea of standardizing things. It just makes the equations a little bit easier. So there's another concept in this. So you might have these alternatives, and we might have to select from these alternatives, and we've got this utility function that helps us translate that into how humans may evaluate these alternatives. But there's another concept that we have to deal with, which is risk. Risk is this idea that there's uncertainty in what we achieve, especially if we've got probabilistic outcomes. Okay, and because of that, we need to maybe incorporate risk into our equations as well. So the way they do that is they do some manipulation of the equations. But first, you need to know there's different types of risk attitudes by humans. So the first risk attitude is risk averse. Risk averse individuals are afraid to seek out risk. Given the choice between the status quo and going out and taking a chance or something, they'll probably take the status quo. Risk-seeking individuals are willing to take a chance to get a higher payoff. The kind of people that are willing to take a bet or play the lottery, etc. So they're risk-seeking in that sense. And then risk-neutral individuals are indifferent. These are like the ideal player that would have paid the St. Petersburg paradox that we talked about earlier, and they are completely indifferent to the risk that's out there inherent into the system. They look at things in a very clean, precise, probabilistic way. So just a couple of examples just to help reinforce this. So you might have risk-averse behaviours when you just carry on doing the normal, what you've been doing before, because you know it's safe and you know what's going on, as opposed to taking some chance with some new process. Risk-seeking behaviour may be when you're saying, well, hey, there's this new technology out there that we could use. Let's move forward. Let's use that technology, or let's try this new process in our system. So, it's not proven yet, but hey, we're ahead of the curve if we do this. So how does this all translate what we've been talking about into actual equations? Well, here's the equation here. So the utility function will be of the form x to the y, where if y is less than 1, if they're risk averse, will be greater than 1 if they're risk seeking. Okay, and the idea behind this is that more risky propositions may lead to higher payoffs, but those payoffs get doled down a bit if you're risk averse, or exacerbated a bit if you're risk seeking. Okay. So the final thing we're going to do is we're going to actually just construct our own utility function. We talked about the different aspects in it, and this is one way you can do this. So first thing to do is just think, what is the smallest amount of money that I'm just indifferent to losing? Is it a penny? Is it $1? Or are you of an individual that you cannot possibly have lost any money at all? So that's your first starting point. The second one, what to think about is how much money is enough. Literally, how much is enough? What would be too much for you? Okay, now what we want to think about is a new value. So this is u to the half. And what we're doing here is just saying, well, okay, if I said to you there's a 50% chance you're going to get your minimum and a 50% chance of getting your maximum, what is the amount that you would need to take at an absolute minimum? So in completely different, this that you would be. It doesn't matter if you take that amount or you take the bet of the 50% minimum, 50% maximum. Okay. And now what we can do is then we can repeat that process. So well, let's take that u half now that we've just generated. That's potentially got 50% chance of getting that, or 50% chance of getting the u minimum. What's the amount in the middle of that that you would say, oh, if you give me that much, I'm indifferent between taking that bet and taking that amount of money. And then I repeat this again, the other side. And you can keep on dissecting the line so you get a more and more clearer utility function. So here was mine that I came up with. So $1, how do you think $1 or less? I don't know, it just doesn't bother me if it goes missing. I have in the past though pointed out that when a waitress has put on an extra 10 cents, so maybe I'm giving a stated preference there as opposed to actual preference. And this is something, so to me, 10 million maximum. I could do anything I need to do 10 million. I would not need more than 10 million. So to be honest, I'm happy 10 million is my maximum, and these are the values that I worked out in between. Yours won't necessarily be the same as this, but I do recommend doing this exercise. I also recommend freshening it out, have an 1/8, have a 16th in there as well, just to give it a bit more of a shape. You'll notice that mine has a very sharp turning point because obviously I've only used a few number of points in it.